Hi, everyone, and welcome back to another planetarium show. My name is Jessica. I'm the director of the planetarium, and with me tonight is one of the students who works in the planetarium, familiar face to those who've been here before, but I'll still let him introduce himself.
Hi, my name is Eli. I'm a physics and astronomy student at UMD.
So tonight is our March iteration of Ask an Astronomer. We are here to answer your questions. So whatever burning questions you have, leave them down in the comments, and as we get those, we will start answering them. Feel free to throw anything you want. We haven't been stumped yet.
Well, we've employed the help of a certain search engine.
There's nothing in the rules that say we can't use Google to assist us.
That is true.
But while we wait and see your questions coming in, we do have a couple of cool things to talk about that have happened over the past few weeks. And I think we should start. Should we start with the Milky Way picture? I think I'm gonna start with the Milky Way picture. So, just released by an astrophotographer
Oh, we already have a question.
was. Oh, awesome!
Not related to the Milky Way, so should we do that one up front?
No, let's do the question. We're here to answer
All
questions.
right, we've got two questions. First, what is a dwarf planet? I'll let you take that one. You know.
Dwarf planet. Good question. So, a dwarf planet is defined to be an object that goes around the sun, is large enough to be spherical in shape, but is not large enough to have cleared its orbit. And this all started because we started finding lots of things in the same area as Pluto out past Neptune. And so we had to make the choice of, if we call Pluto a planet, do we call all of these things a planet, or do we come up with a new category? And that's what they decided to do, with the defining line between planet and dwarf planet being that large enough to clear its area. Pluto orbits in this region called the Kuiper Belt, which is a lot like the asteroid belt, but for icy debris. And since there's a lot of other things that intersect its orbit, that orbit with it, it's classified as this dwarf planet because it's not quite big enough to be the dominant object there. And so, yeah, that's what a dwarf planet is.
Boom. All right, next question. If we could mine the planets, what would we find? Gold, silver, uranium, liquid, solid?
So a lot of the same stuff that we have here. I mean, the Earth and all of the planets were made out of the same big gas cloud that condensed and formed tiny little solid particles that then built up bigger and bigger and bigger to end up forming planets. And so they're all made up of pretty much the same stuff. Here in the kind of Earth and the rocky world, so Mercury, Venus, Earth, and Mars, because they're so small, they didn't pull in a lot of hydrogen that was in the gas cloud. And so we find those rocks and metals predominantly here. Out, huh?
Lots of iron.
Yeah. And then out in the outer planets, Jupiter, Saturn, Uranus, and Neptune, they also have those same rocks and metals. But because they got so much bigger, they also pulled in a lot of hydrogen and helium. That just Earth wasn't big enough to hold on to. Its gravity wasn't strong enough to hold on to that. And so they were able to grow even bigger because there's a lot of hydrogen out there. I mean, that's the most common thing found in the universe. But they're still made up of the same types of materials, just in different proportions.
And then also correct me if I'm wrong, but one of the other professors in the physics department talked about this when I took his class a while back. And he said that the outer planets, namely Jupiter and Saturn, have liquid hydrogen, which he said is also what we use for rocket fuel. So there's just like large amounts of rocket fuel out there
Mm-hmm.
that we could use. Except the problem is that we'd have to get to the liquid layer, which we would get crushed before that happens.
Yes. And to keep it in a liquid as you move out, you'd have to mimic those conditions. Um, but yeah.
The next question we got is kind of funny, depending on how I word it. I'm gonna go with the past 8th grade wording. Does Uranus rain diamonds?
Short answer, yes. We think, possibly. This is actually one of my favorite facts about both Uranus and Neptune. Because they have a lot of methane in their atmosphere, and methane is made up of carbon and hydrogen. And so when you get that carbon interacting with other things under those intense pressures and temperatures, you can end up stripping that carbon out of the methane and squeezing it into a diamond, which then would fall because it's heavier than its surroundings. So yeah, Uranus and Neptune may very likely be raining diamonds, which is just crazy cool.
So then something I've wondered about that. So the raining diamonds, it would happen at a certain layer, but then I guess this doesn't make sense now that I think about it. But after it rained the diamond for a while, what would happen? For some reason, I thought it would turn into a liquid or like disassemble again, but that doesn't make sense.
I'm not quite sure because I don't know the pressures and temperatures diamond can withstand.
Yeah.
So it will either fall until it's no longer denser than its surroundings, and
Right.
then it will just float there. Or if it does reach its extremes, then yeah, it would get destroyed in the depths.
Right. Okay. Cool.
Yeah.
The next question we got is probably a good jumping point because I'm gonna have to get out a pencil and paper. Uh, but it's how much would a 140-pound person weigh on each of the other planets? I doubt I can look that up, but I can do that
I'm
quickly about the Milky Way.
fairly certain there is a calculator online.
All right, hold on.
Yeah. So
I'll get back.
so I'll give a little bit of background. Our weight that we measure on a scale is a combination of our mass, how much stuff makes us up, and the pull of gravity, Earth's gravity pulling us down. And while the amount of stuff that makes us up doesn't change as we were to go to different planets, the planets all have different gravity pulling on you, and so your weight that you would measure on a scale would change. If that gravity was a lot stronger than we have here on Earth, your weight would be higher. If it's a lot less than what we have here on Earth, your weight would be less. So, like for the moon has 1/6 of Earth's gravity. So 140 pounds, if you weigh 140 pounds on Earth, you would be 1/6 of that on the moon. Which I have a calculator right here.
23.2.
There you go. That is how many pounds you would weigh on the moon.
Right.
And so, in order to figure this out for the other planets, we really just need to know how their gravity compares to Earth's. And I'm fairly certain there's a calculator somewhere online.
I got it.
You got it?
So for Mercury, you would weigh about 53 pounds. On Venus, which I expected to be closest, but it's actually not, you would weigh 127 pounds about. On the moon, you would weigh about 23 pounds. On Mars, you would weigh about 53 pounds. On Jupiter, you would weigh 354 pounds. On Saturn, you would weigh 150 pounds, give or take. On Uranus, you'd be about 125. And then on Neptune, which is actually the closest, you would weigh about 158. And then on Pluto, you would weigh 9.3 pounds.
Do you want to link that in the video?
But then the other interesting thing that I always think about with stuff like that is when you're talking about weight and how much you would weigh, you kind of need to specify that you're seeing how much you would weigh like on the surface, which gets kind of messy for the gas giants because the closer you get to the center of mass, the more you're going to weigh.
Mm-hmm. The stronger gravity is.
Right. So
and those outer planets don't have a solid surface.
Right. So there's not really like a defined boundary. I just posted the link for the little calculator so you can see how much you weigh on different planets.
Very cool.
We also got another question. It is how big is the Oort cloud, which is a question from their grandson LJ. It's also kind of an interesting, weird boundary question.
This is a good question. So the Oort cloud is this huge spherical distribution of icy stuff out on the very outer reaches of our solar system, well past the Kuiper belt, which sits past Neptune. And we haven't directly seen the Oort cloud,
Mhm.
We have inferred that it exists based off of the orbits of really, really long period comets, those that take thousands and thousands of years to loop around and come back. That's told us that there has to be some big distribution of icy stuff really far out there. And so we think that the Oort cloud extends about a light year from the sun, which is 6 trillion, 6 trillion miles.
I
I
should
believe
know
that's
that.
right.
I'll look it
It's
Yeah, about 6.
so that's about a fourth of the distance to the next star. So we're talking the Oort cloud is getting out far enough to be in the realm of the stars. And we actually think that's one of the reasons we have those comets coming from the Oort cloud is a star passed nearby, disturbed those icy objects out in the Oort cloud and sent them flying into the inner solar system, creating those long period comets. So yeah, and it's kind of cool how we think it formed. We think that this is a result of things like Jupiter and Saturn and even the Sun in the very early solar system slinging things out of our area, out of the inner solar system. And these are things that got slung so fast that they were able to travel really far, but not quite fast enough to fully escape the sun's gravity. And so now they all live just really, really far away out in the very outer reaches. It's kind of thought of as like the outer boundary of the sun's gravitational influence, which is very cool.
Yeah, but again, it's one of those like weird like boundary like there's not the most comparable one I can think of is like Earth's atmosphere. Like there's
Mm-hmm.
not like a hard stop where it's like atmosphere then space. It's kind of one of those things where it's like it's kind
Gradual.
of a great yeah.
Yeah.
Just
Oh, these have been fun questions.
yeah.
Anything else yet?
Nope, nope. I'm assuming they're all using the weight calculator currently. So
All right. Well, I want to show off this picture of the Milky Way while we are waiting to see if any more questions come in. So what I want to show you is, let me switch over. There we go. This view here of the Milky Way. This is a picture that was taken by an astrophotographer, J.P. Mezzavano, I think is how you say his name. But
this isn't an official image. This is just something that
no, this is
someone
someone that someone just decided to do for fun.
wow.
Yeah, so this isn't a NASA image. He spent 12 years collecting images of the Milky Way, totaling over 1,200 hours of exposure time to create this insanely detailed image of the Milky Way. Because it's over 1,200 hours, you can see really well all of the gas that is within the plane of our Milky Way, how it all swirls, and I mean, it's just is beautiful. And I know through the stream, it may not look, it depends on the quality that my computer is streaming at right now.
It
Um,
looks pretty good.
but we do have, I have the link to his blog post where he posted the information on this in the video description so that you can go and take a look at this yourself because it is stunning and definitely not a view of our galaxy that we're used to. Because this is stuff that you don't see with your naked eye. The light's too faint, and this is what happens when you just sit and collect that light for over 1,200 hours. You reveal so much that is previously unseen. But it's gorgeous.
Okay, so we got two more since. Another one from the same grandson, LJ. How hot is the Earth's core? And the answer to that is about 5,200 Celsius, which is just shy of 10,000 Fahrenheit, which is just shy of the temperature of the surface of the sun.
Mm-hmm.
Um, and then the next one is what progress has the new Mars rover made since landing, which is probably a good segue
Yes,
into
it is. And that was from my mother. Thank you, Mom. It's like you read my mind. I totally didn't set this up. Um,
Oh, I'm
I
sure.
didn't, I swear. She just knows me and knows how much I want to talk about Percy.
Yep.
So there have been a lot of really cool things going on with the Perseverance rover. If you've missed that, they have put out some amazing just videos of the landing. And first, there was sound from the very first few days when it had its microphone on, and you can hear the winds blowing on Mars. But one of the more recent things that they have released is the sound of Percy actually driving around Mars, which I'll play.
Oh, I can't hear it. I have the stream volume turned down.
All right, I'm gonna stop it there. I'm not gonna play the whole 16 minutes for you guys. If you do want to hear it, again, link is in the video description. So yeah, Percy is doing great. Operation, everything seems to be working great. She's driven around. That seems to be good. She just dropped one of the under covers. That is where she goes to collect samples. That they're working on a future mission to come and collect those samples and bring them back to Earth. So a lot of good things. One of the most exciting things is we are getting very, very near to the Ingenuity helicopter being dropped off of Percy and taking its first flight. They are estimating that that should happen first week of April. And so we are weeks away from the very first kind of flight on another world, which is kind of crazy. But I'm very excited and looking forward to that. They can't give a specific date because it's going to depend on wind and weather conditions. They're waiting for an ideal, opportune moment. But yeah, that's coming up, and you can absolutely bet we will tell you when it happens. There's no way I'm not talking about that.
How long are those flights supposed to last?
I don't know. I mean, I know at the very most they want to get a flight to prove that they are in flight and not just like falling, that they have controlled flight. And that's really the biggest goal. I mean, that's the proof of concept showing that you could fly a helicopter. After that, I think it's just going to be the team having fun and seeing what the limits are.
Yeah. Yeah. Well, no more questions. So on to.
All right. Well, another story that's come out about Mars that Perseverance is actually going to help shed some more light on is where all of the water on Mars went. If you didn't know, we think that about 4 billion years ago, Mars was covered in lots of liquid water, very much like Earth is. Not quite as much water as we have here, but a significant amount that it would have had some pretty big kind of oceans on its surface. And it was initially thought that about 3 billion years ago, Mars lost most of that water because it escaped into space, evaporated and escaped. But a recent study that's just come out suggests that that may not be the case. That most of the water may actually be trapped in minerals in the rocks rather than have escaped into space. So that water that was there may actually be trapped in the crust, which is really cool just for us to know kind of what happened. But that also does mean that there could be a significant amount of water on Mars that we could maybe extract from the rocks. I mean, it's not an easy process, but knowing it's there could make having humans and have a civilization there maybe a little bit easier. Um, but yeah, so more fun stuff. And then Perseverance again, by being able to study the rocks, it'll be able to get more samples and actually measure how much water is trapped in the minerals, and can give us a better understanding of this. Yeah.
So we did get another question, not related to Mars. It's what is the biggest galaxy? And
I
after
believe
a
that's
quick
M82, right?
No, it doesn't look like it. That would probably be the biggest spiral.
No,
Nope.
M82 is the giant elliptical galaxy, right?
Okay, maybe I'm getting a different. Maybe I'm getting a different identification. But on my first search, I found IC 1101.
Oh no, not M82. M81, I think, is what I'm thinking of.
Maybe it has the same
No.
cross identification. Or is that Bode's galaxy?
Is M81 Bode's? Yes, it is. What am I thinking of? This is the problem with the Messier numbers.
It's the problem with having 8 different identifications. But on my first search, what galaxies? Yeah, it doesn't look. It's IC 1101, which is a giant elliptical galaxy, and it is its halo extends 2 million light years from its core,
Oh.
and it has 100 trillion stars in it.
And
I'll bring.
one of the largest domed black holes at its center.
Yep, I have a picture of it right here if I can screen share.
Yeah, let me. Sorry, I always forget to do that in the beginning. There you go.
No worries. And admittedly, it doesn't look super exciting because it's an elliptical galaxy, but
That's
there
it.
you have it. That's IC 1101, which is the biggest galaxy that we know of. 100 trillion stars. Just for reference, the Milky Way has
It's about 2 billion.
2 billion. Yep. So
Yeah.
just a hair more.
Just a little bit.
Yep. Just a tad.
Oh, this is gonna bug me if I can't remember the galaxy.
It's a Messier?
Yeah. The one with the hold on.
The pinwheel?
Lindsay would know if she was here. M87.
Oh. Oh yeah. Because that's the biggest one in what's the cluster?
Virgo.
Yeah, it's the biggest one in Virgo, isn't it?
Yeah. And this one
Oh yeah,
is.
it has the jet. That's right.
Yeah,
That's
the jet.
right.
This is the one that we imaged the black hole.
Yes.
Which, by the way, if you're interested in that, we're going to talk about black holes next week.
Yep.
This is completely riveting as we're both like reading.
Yeah.
I'm trying to. Okay, so I was wrong. M87 is not. IC 101. Is that what you said?
1101.
1101.
Sorry, 2101.
There you go.
But yeah.
Very cool.
Cool. The biggest ones are usually elliptical, which is kind of lame because they don't look exciting.
That's what happens. Galaxies grow that big by smaller galaxies merging together. And when galaxies merge, that disk shape of spiral galaxies like ours or the Andromeda, that gets disrupted. So big galaxies, because they grow from merging lots and lots of galaxies together, you don't keep that disk in it. They stars get all jumbled up, their orbits get all jumbled, and so you end up with just this spherical blob of a galaxy.
We got another question. Would you fit all the planets together between the Earth and the Moon? Yes, with a little room to breathe.
Yep. It's,
including Saturn's rings, right? Or is it not including?
No, not including, because Saturn's rings are the same from one end of Saturn's rings to the other. That's the same distance as the Earth to the Moon.
That's right. Yep. Thank you.
Yeah. So if it was kind of turned on its side. Mm-hmm. But yeah.
So kind of another way to think about it, you can fit all the planets in Saturn. That's also kind of interesting.
Yep. Things are really big in space. It's hard to grasp that because in order to show it in like pictures and books or anything, you kind of have to squeeze everything together to make them fit. But yeah. All right. Well, I did have one more thing that I had saw about Jupiter, actually. Many of you may know that it has the giant storm called the Great Red Spot that has been going on for over 350 years. We've also noticed that it's been getting a little bit smaller over the last few decades. So it used to be about 3 Earths in diameter, and now it's only about 2 Earths. And so there was a study being done to see if it was interactions between the Great Red Spot and smaller storms that were causing it to get smaller. And what they found was really interesting. Um, Interactions with these storms does cause the surface layer to get smaller, but the overall depth of the storm and the strength of the storm doesn't change. And so they actually think that it's this interaction with smaller storms and possibly even, gobbling them up, could be what's sustaining the Great Red Spot and why it's lasted for so long. It's basically taking energy from these smaller storms, and that's keeping it going. And so while on the very surface it may look like it's getting smaller, it doesn't actually seem to be getting any weaker, which is really cool. Nice step towards our understanding there, because that's been a mystery for as long as we've been observing Jupiter, really. All right. Well, that I think is all of the cool things that I had found for today. We've also had a lot of really great questions.
Yeah.
If you are interested in reading up on any of these topics that we've talked about, I've linked the news articles. So for things on Perseverance, the Jupiter storms, the water on Mars, and that image of the Milky Way, all of those are linked in the video description.
We just got another one, and I'm not.
How strong is Jupiter's storm?
I'm going to answer that in terms of wind speed.
Yeah.
So at the storm's center, it's actually usually calm, like we see in hurricanes on Earth.
Yeah.
But at the edges, the wind speeds can reach up to 425 miles per hour. And comparing that to the fastest hurricane on Earth, that is about twice as strong.
Yeah, about twice the wind speeds. Which I think didn't I have you do this as an activity in class last semester?
Yes, I think you
I'm
did.
pretty sure.
The Jupiter's hurricanes. Yeah, that's right.
Yeah.
Yep. General astronomy. Astronomy 2050.
Yeah, I thought this sounded. It was like I actually think I know that number.
Yeah.
Yeah, it was about 2 to 3 times.
Yeah. Yep.
Yeah.
Cool.
Which is cool.
Yeah. I definitely did not Google that. I was checking my notes on Google Drive and those numbers.
Yeah, that's what that keyboard typing was.
Yeah.
Definitely not Google.
I typed in the full URL to the document in Google Drive. I didn't go through the portal, so it took me a minute.
You're good. I didn't even remember the number. All right.
All
Well,
is quiet in the questions right now.
yeah. We will pause for just a few more minutes to see if any more questions do come through. While we do that, let me tell you what's coming up over the next week.
Never mind, we got another one. Should we come back to it at the end?
Yeah, let me go through the next week and then we'll come back to the questions. So Wednesday, we are doing our last show in our series for Women's History Month. We're going to do Women Making History. So this is taking a look at the current women in astronomy and STEM and all of the amazing things they've done, including Burchin, who was a student at UND, and she found... Yeah, you've actually got to talk to her, which I'm jealous of.
I just got an email from her. Yesterday.
But she discovered this really cool, different kind of galaxy. We're going to talk about Katie Bowman, who was responsible for that first ever image of a black hole. So a lot of amazing work still being done by women in STEM and astronomy. And then next Saturday is our next show in our exploration series that we just started. And we are going to be looking at black holes because we always get asked about them, and I have been dying to do a show about them. So we are finally doing a show on black holes, and that will be next Saturday.
Thank you.
And I am excited. And if So this exploration series is pretty new. This is only the second show we've done, with the idea being we want to go kind of in depth into the topics that you want to hear about. So if at any time you do have suggestions or topics that you want to hear, let us know, and we will add them to our list of things to do for the exploration series. All right, so you said we had another question.
Does Saturn have a storm? And let me show you. Yes, it does. And the weird thing is that they are hexagonal. Am I showing the right screen now?
Yes.
Yeah, so they are hexagonal. That's a
And
storm
to note, yeah, you're about to say, this is at the North Pole or the South Pole?
This is the North Pole. And we don't know exactly why it happens that way, but we are trying to figure that out. And they're really cool to look at, but we can only see them every so often because Saturn only faces that way every so often. But yes, there are storms at Saturn, and it also has like storms sparse throughout, but the most notable ones are at its poles, and they are hexagonal.
And it probably does have storms at mid latitudes too, just like Jupiter does. It's just a lot of the clouds on Saturn sit deeper in the atmosphere. Since Saturn is further from the sun and it's colder, those clouds sit deeper in the atmosphere. And so it's very likely that they're there. We just can't see them very well because they're hidden.
So they're big ones.
Yeah.
At the poles.
Which is cool. And I think in our Beyond Bizarre show, we talk about this a little bit, which we'll probably do that again soon.
Yeah.
So we may look out for that. We may end up doing that one soon. But yeah. All right. Well, I think that's everything.
Yep.
So yeah, thank you everyone so much for joining us. Thank you for the amazing questions. This has been a really fun show. I know it's one we like doing because we like hearing from you guys and being able to answer your stuff. And we even learned things. Like I didn't know M87 wasn't the largest. That's what I thought.
So I think someone asked that like a week ago, and I looked it up. I looked it up for some reason like a week ago. But yeah, there you go.
All right. Well, if you enjoyed the show, we do regularly stream on Wednesdays and Saturdays at 7 p.m. We've also been doing private not live streams, private virtual shows. We've done some birthday parties. We've done some field trips. If you're interested in possibly booking that, you can find information on our website. And yeah, I think we will wrap it up there. So thank you again for joining us. We hope you have a wonderful rest of your evening, and we will see you again next time. Bye, everyone.